Hello children, today we are going to solve some numericals of kinematics. These questions are from the chapter Motion in 1D of class 11th. I've also brought some formulas which will be useful for you in solving these questions. And here are some chems. And now the question. The first question says, okay, before we begin solving these questions, my advice is that you learn differentiation and integration before you solve the questions of motion in 1D. That will be very helpful. Now let's get to the questions. Question 1 says, a balloon is ascending vertically with a uniform velocity of 10 meter per second at a height of 75 meter above the ground. A stone is dropped from it. Take g is equals to 10 meter per second square. All the units are homogeneous, so we do not need to convert the units. The total time taken by the stone to reach the ground. Time is to be found. This is the question. We have to find the time. There's a hot air balloon which is ascending, means it's going up, and the velocity of the balloon is 10 meter per second. We must keep in mind, जब balloon हवा में है 75 meters above the ground, then the stone is dropped, so the initial velocity of the stone will be same as the velocity of the balloon. So initial velocity of the stone will be 10 meter per second square. Let's assume that all the quantities upwards will be taken with positive sign and this will be taken as negative sign. We will use this for solving the question. So we are taking the initial velocity with positive sign because the balloon is ascending and its velocity is same as the initial velocity of the stone. Now the distance, the balloon is at 75 meter above the ground when the stone was dropped. The stone got dropped from the balloon. Here we have the balloon and the stone got dropped, and this is 75 meters. So here this will be taken in, the displacement will be taken with negative sign. Okay, and acceleration due to gravity always acts downwards, so acceleration due to gravity will also be taken with negative sign. These are the quantities given to us: initial velocity, displacement and acceleration. We can use these in the following equation: s is equals to ut plus half at square. We can apply these values, put these values, and then solve the equation to find t. So s is here minus 75, u is 10t minus half 10t square. When we simplify it further, we get the equation minus 75 is equal to 10t minus 5t square. 5, 10, 75, all multiples of 5 can be simplified. Minus 15 is equals to 2t minus t square. Now let's get all the values on one side. T square minus 2t minus 15 is equals to 0. This is a quadratic equation and we can solve this quadratic equation. Minus 2t can be written as minus 5t plus 3t, right? And when we solve this quadratic equation, we will get t minus 5 and t plus 3 is equal to 0. Okay, by equating this with 0, we will get t is equals to 5. By equating this with 0, we will get t is equals to minus 3. Time cannot be minus 3, so the answer is 5 and C option is correct. Now the next question. Question number 2 says, a particle is moving along x-axis with its position varying with time as x is equals to Okay, this should be written as x as function of time since it is varying with time. So uh, ignore this. Xt is equal to alpha t to the power 4 plus beta t square plus gamma t plus delta, the ratio of its initial velocity to its initial acceleration is. Okay, so we are supposed to find the ratio of initial velocity to initial acceleration. This is what we have to find out, right? So let's write the expression for the position. Xt is equals to alpha t to the power 4 plus beta t square plus gamma t plus delta. This is the expression for position. We know, we will first find out Vt, then we will find out V naught. We will first find out the general expression for velocity, then we will find out initial velocity. Initial velocity is being called V naught because initial velocity will only be found at t is equals to 0. Uh, Initial acceleration will only be found at t is equals to 0, right? That is why I am calling that V naught and A naught. So let's find out Vt, then V naught, and then At, then A naught. Okay, getting to the solution. For Vt, we know that the differentiation of position xt, so Vt is equal to differentiation of xt, right? dxt by dt will give us the expression for Vt. So we will differentiate this expression. Let's write it down over here. d by dt alpha t to the power 4 plus beta t square plus gamma t and delta. On differentiating it, we will get 4 alpha t cube plus 2 beta t plus gamma. Now this is the expression, general expression for velocity. For V naught, we know that t has to be equal to 0. Putting the value here in this expression, we'll get V naught and ये भी 0 हो जाएगा, this will also be 0, only this will be left, only gamma will be left after putting t is equals to 0 in the expression of Vt. Okay, so V naught is found, V naught is equal to gamma. Now let's find out A naught. For that, we will first find out At, and general expression for acceleration is equal to d Vt by dt. Now on differentiating velocity, we will get acceleration. So let's differentiate velocity. This is 4 alpha t cube plus 2 beta t plus gamma. On differentiating, we will get 12 alpha t square plus 2 beta. This is the expression for acceleration. Now A naught, which is initial acceleration, will be found at t is equals to 0. So putting t is equals to 0 in this expression, we will get A naught is equals to 2 beta. This will be 0 and this will be left. So A naught is 2 beta. Now V naught by A naught is equals to gamma upon 2 beta. This matches option B. Next question. Next question is question number 3. The acceleration of a particle is related to its velocity as A is equals to kv, where kv, interesting, where k is a constant. If velocity at t is equals to 0 is v naught, the velocity at time t. So we are supposed to find v t. Here, the expression for acceleration is given and we have to find velocity. When we go from x to v to a, then we do differentiation, right? And when we go from a to v to x, we do integration. You can keep this in one of your chems, that when we go from x to v to a, x stands for displacement, v stands for velocity, a stands for acceleration. So this way we use differentiation and this way we use integration. Now let's get to the question again. Expression for acceleration is given and we have to find velocity. Let's write down the expression for acceleration. A is equal to kv. Now A can also be written as dv by dt and this is equal to kv. If we transfer velocity here, and this expression then becomes dv upon v is equals to k dt. Now on integrating, let's see what we will get, because as I told you, when we go from a to v to x, we have to use integration, and we are going from a to v, so we will have to integrate, right? Let's integrate. So we will do integration, and here let's put the limits of integration. Let's use the information given in the question first. So at t is equals to 0, v is v naught, right? And at time t, the velocity, let's assume velocity to be v, okay? Let's go with that and then solve it. So we know that the log function is the answer for this. If you know integration, then you would know that integration of 1 upon x is log x, right? So here dv upon v, this will give us log v, natural log v, integrated from v naught to v, and this will give us k t integrated 0 to t, right? Now on solving it further, we will get log v minus natural log v naught is equal to k t minus 0. Now if you know the rules of log, then you would know log x minus log y is equal to log x by y. So this can also be written as log v by v naught, and this will be kt. And if you know the exponential function, then you would know that this can also be written as v by v naught is equal to e to the power kt. This is the use of exponential function. Then v is equal to v naught. We are just simplifying the equation using integration, log function and exponential function. These are the basic things that you will need to solve any numerical of this chapter. So please go through it before solving these questions. Now this is the expression that we have got, and do we have any similar option? I think option B is our answer. Now next question. Two particles A and B start from the same point at the same time. Same point and same time. A moves with constant velocity 10 meter per second. B starts from rest with uniform acceleration 2 meter per second square. The distance from the starting point where B overtakes A. I will take your time in explaining this question, but you need to understand it fully before you get to solving this. So, two, two particles A and B are moving. A, let's assume this is A, let's assume this is B. Now, two particles are moving from same point at the same time. Okay, so let's say this is the same point and they have started moving at the same time. A moves with constant velocity, A and B. Its velocity is given and B's acceleration is given. And there's no acceleration for A. Acceleration for A is 0. It is moving with constant velocity. And for B, B starts from rest. So initial velocity of B is 0, right? This is all given in the question itself. Initial velocity for B is 0. We don't know the initial velocity for A, but velocity of A is given, and we will assume that its initial velocity is 10. Okay, because that's constant, that has been constant, its velocity hasn't changed. And it's not mentioned that A is starting from rest, so we will assume that its initial velocity is 10. Now, do we have something else? Now, question is saying the distance from the starting point where B overtakes A. At some point on their journey, B is about to overtake A. They both are still moving, but B is about to overtake A, and the point at which this happens, that distance, that displacement has been asked. Now, this is the point where they both are together and the displacement of both A and B would be same. After that, B would go further ahead and A would be falling behind. But till this point, they are together. Their displacement is same. So S is same and the other things are given here. Let's use this to solve the question now. So let's use the expression of S is equals to UT plus half AT square for A and B. So S is same for A and B. We have to keep that in mind. S is same for both, but we will get two different expressions. So SA, do we have initial velocity of A? Yes, we have initial velocity of A as 10, right? So 10t plus half A. Acceleration of A is 0, so plus 0. Also, we will use the same time, same expression for time, because by the time they will reach this point, the same time has been taken by A and B both, right? So we are taking t as the expression for time for both of these. Now, SB is initial velocity given for B? It is 0. So this expression becomes 0 plus half A t square. A is given, so we will further simplify this, half into 2t square, and SB becomes t square. So we have SA as 10t, we have SB as t square. Equating both, we will get 10t is equals to t square and t is equal to 10. By putting this value of t in expression for SA, we will get SA as 10 into 10, 100. So the answer, the displacement is 100 because SA and SB are same. Next question. A particle moves along a straight line such that its acceleration depends on position as a is equals to minus kx. If released from rest at x is equals to a, the maximum speed attained. This is especially for JEE Advanced. If you are not preparing for that, you do not need to bother about this question. But those who are preparing, pay attention please. If you are preparing for JEE Advanced, then you will be able to identify this expression. It represents SHM, and we can use the concept of SHM to understand the question fully. So here, if released from rest at x is equals to a, the particle is at x is equals to a. It is here, and from here it is being released and it is going in this direction. Now it is going towards the equilibrium position. If released from rest at x is equals to a, the maximum speed attained is we know that velocity at this point is 0 and maximum velocity is attained at equilibrium position. We will be using this. That is why I'm explaining all of this to you. So at equilibrium position, the maximum velocity is attained, and at equilibrium position, we know that x is equal to 0, right? Here at this position, x is equals to a, and at this position, x is equals to 0. Now we will use this to simplify this question and get the answer. We have to find maximum speed attained, and expression for acceleration is given. I just explained when we go from a to v and v to x, we use integration. So we will be using integration as we are going from a to v, right? So let's write this expression once again. A is equals to minus kx. Okay, a can also be written as dv by dt, and it can also be written as dv by dt into dx by dx. We know that dx by dt represents v. So v dv by dx also represents acceleration. We will use this expression for acceleration and then solve it further. So v dv by dx is equal to minus kx. Now let's simplify it further. V dv is equals to minus kx dx. And now we will integrate. Let me write it properly. X dx. We'll integrate this, and on integration we will get, this will be integrated from, velocity will be integrated from 0 to v as the object is being released from x is equals to a, right? I'll make it again for you if you want me to simplify it. This is x is equals to a. At this point, the velocity is 0. This is x is equals to 0, and the velocity at this point is maximum, right? V. So it is released from x is equals to a. So it is released from a and it goes to 0, right? It goes to 0. X from a to 0 is our limit of integration. Now here for velocity we will go from 0 to v, from 0 to v, and now we will integrate. Clearing the board for you. Now we will integrate. On the integration we will get v square sorry v square by 2 0 to v, which is equal to minus half. I'm skipping a few steps. Please solve it properly if you want to. If you know integration, then it's easy peasy for you. A to 0, right? On integrating, this is what we get. Now, putting these values, you'll get v square by 2 minus 0, which I'm not writing, equals to 0 minus half kx square, which will be half ka square. And cancelling these, we will get v square is equal to ka square, and v is equals to a root k. A root k, C option is correct. That's the answer. Here's your bonus question. Pause the video, solve it. Thank you.